Good morning. Welcome to today's news briefing by the Department of Commerce's National Institute of Standards and Technology as we release for public comment the draft report of our study of the Joplin tornado of May 22nd, 2011. I'm Michael Newman, Senior Communications Officer for Nist. I'll be moderating today's news briefing, and we welcome also those of you who are joining us via webcast. Our presenters today will be Howard Harari, Acting Director of the Nist Engineering Laboratory, and Eric Letvin, Director of the Nist Disaster and Failure Studies Program. You'll hear from them shortly. I'd like to go over quickly some logistics for today's briefing. Your press packets, for those of you who are here, contain a number of items to help you cover the story, including the press release, copy of Mr. Letvin's presentation, and a copy of the draft report from our study. For everyone else, all of these items are available via the online news release, which should have been posted by now, at www.nist.gov. Following Mr. Letvin's presentation, we will take questions from the media only. We ask that reporters here in Joplin with questions, please raise your hand and we will bring a microphone to you. When recognized, please state your name and the name of your organization, and then before asking your question. For reporters watching the webcast, we are also providing a way for you to participate in the Q's and A's. Please send your questions via email to Joplin Media, all one word, Joplin Media @nist.gov. Please put your name and organization in the email so that we'll be able to see that and identify you along with the question that you have. The question and answer period and the official activities of this briefing will end sometime around noon. We'd like now to proceed. I'd like to introduce Dr. Howard Harari.
Good morning. My name is Howard Harari. I'm Acting Director for the Engineering Laboratory at the U.S. Department of Commerce's National Institute of Standards and Technology in Gaithersburg, Maryland. I'd like to welcome everyone to the news briefing about our technical investigation of the devastating tornado that struck Joplin on May 22, 2011. We're releasing a draft report on the investigation today, and we'll be accepting comments from the public over the next month and a half. Eric Letvin, Director of the Nist Disaster and Failure Studies Program, will briefly summarize his team's findings and recommendations in just a few minutes. But first, I'd like to give you a quick introduction to NIST and to the background for the investigation. NIST's mission is to advance U.S. innovation and industrial competitiveness. We do this in many different ways. Most relevant to our topic today is NIST's long history of helping the construction industry improve the resiliency and safety of buildings through recommendations for improved model codes, standards, and practices. NIST has been conducting disaster and failure studies since 1904 and has completed 13 studies of high wind events since 1969. We conducted our investigation of the Joplin tornado under the provisions of the National Construction Safety Team Act. This law specifically authorizes NIST to investigate major building failures where there has been a substantial loss of life or the potential for a substantial loss of life in order to gather lessons learned that can be used to better protect people and property in the future. By studying disasters such as the Joplin tornado, and its impact on the community, we hope to better understand the performance of structures, emergency communications, and human behavior during catastrophic events. NIST is a technical organization, not a regulatory agency. We don't mandate building standards or code changes. However, our experts serve on many national standards committees, and we work diligently with standards organizations, code-making bodies, federal agencies, and other professional societies to encourage the adoption of our recommendation. The city of Joplin, Jasper County, and the state of Missouri suffered a tragedy in May 2011. Just a few days ago on Sunday, dozens of tornadoes struck Illinois and several other states, again killing residents and destroying homes and businesses. It is in everyone's best interest to do whatever we can, as soon as we can, to better protect our communities. We encourage everyone to review our report and provide us comments that will make our recommendations as effective as possible. We will consider all comments received by January 6, 2014, prior to issuing the NIST final report. We can be contacted via email at disaster@nist.gov. Full study information is available on our Disasters and Failures website, linked from the NIST homepage at www.nist.gov. At this point, Eric Letvin will tell you about the Nist investigations and the resulting findings and recommendations. Eric?
Thank you, Howard. Good morning. I'm pleased to be here this morning to talk with you about the major findings and recommendations from Nist's technical investigation of the Joplin tornado and its impact on the community. As Howard has explained, Nist has legislative authority to investigate building failures with the intent of recommending improvements to building codes, standards, and practices. Our goal with these disaster studies is always fact-finding, not fault-finding. To make the best use of our resources, we use specific criteria to carefully choose which events to investigate. The Joplin tornado of May 22, 2011 was clearly an unusually powerful and tragic event. The tornado caused 161 fatalities, more than 1,000 injuries, and damaged close to 8,000 buildings, making it the deadliest and costliest single tornado since official record-keeping began in 1950. Nist deployed a team of experts to Joplin 3 days after the tornado. We quickly concluded that the large number of deaths and specific types of building and infrastructure damage seen with this tornado made it especially important to learn as much as we could about what happened and how lives and property might better be protected from such tornadoes in the future. Our draft report is very detailed and has 47 findings and 16 recommendations. I'm not going to be able to describe them all with you this morning. Instead, I'd like to tell you briefly about a few particularly central findings and recommendations. I'll also briefly explain where additional research is needed to fill in gaps with our knowledge. The overarching conclusion from our 2-year study is that death and destruction from tornadoes can be reduced. Based on a single body of research and observations from such events, our scientific understanding of tornadoes and their effects has matured substantially. It's time to begin developing and implementing nationally accepted standards and codes that directly address tornado hazards. Through stronger construction methods, enhanced emergency communications, and greater access to tornado-safe shelters, we can reduce the tremendous human and economic cost of these events in our communities. We reached this conclusion by studying the following aspects of the Joplin event: tornado characteristics, building and infrastructure performance, human behavior, emergency communications, and the impacts of each on protecting people from tornadoes. To our knowledge, this is the first scientific study to address the intersection of these distinct areas for a specific tornado. Our study team included experts in structural and fire engineering, extreme wind, meteorology and severe storms, and sociology for analysis of human behavior and emergency response. We were fortunate to have essential assistance from a number of different organizations. We want to specifically thank the City of Joplin, the State of Missouri, the National Oceanic and Atmospheric Administration, especially the National Weather Service and the National Severe Storms Laboratory, and the Federal Emergency Management Agency. Our data gathering and subsequent analysis efforts included estimation of tornado wind speed and other characteristics based on observed damage, field surveys of 25 buildings in the damaged area shortly after the tornado, and subsequent review of building designs and structural analyses to determine their performance during the tornado. Analysis of the emergency communications that took place prior to and during the tornado, and a collection of experiences through interviews with 165 survivors, emergency responders, and family members of the victims, and documentation of the pattern, location, and causes of fatalities and injuries attributed to the tornado. We constructed a detailed timeline of the event and created a computer model for estimating the wind environment. The model was optimized by comparing thousands of computer-generated tree fall simulations to actual observations of fallen trees in Joplin. The best comparisons were used to estimate tornado wind speeds and directions. We collected and examined design and construction drawings for some of the Nist surveyed buildings to aid in developing an understanding of the sequence of failure for these structures. Through speaking with tornado survivors, we also developed a detailed understanding of the public response before and during the tornado. We're grateful to many of the Joplin residents who provided information through face-to-face and telephone interviews, as well as those who helped us to recruit people to interview. To determine the effects of emergency communications on behavior, we studied the emergency communication systems in place in Joplin and Jasper County in May 2011. In addition, we conducted a qualitative analysis of other tornado warning systems throughout the United States. We reviewed death certificates and obituaries, interviewed friends and families of victims, and collected news media and social media reports. We then combined this knowledge with the analysis of the wind environment and building performance, and identified the factors that likely caused the impact-related deaths and severe injuries that resulted from this tornado, both outside and inside of structures. We found that in most cases, neither residential nor large commercial buildings in Joplin adequately protected building occupants. A large majority of the fatalities, almost 84%, were due to impact-related causes associated with building failures. Virtually all the buildings where the fatalities occurred experienced maximum estimated wind speeds associated with EF3 or higher on the Fujita scale. There were no community shelters in Joplin in May 2011, and residents had limited access to underground or tornado-resistant structures. The outdoor emergency sirens alerted many people that an emergency was occurring. However, conflicting information from multiple sources caused confusion for many residents about the true nature of the hazard. As a result, many people sought additional information rather than immediately seeking shelter. A delayed or incomplete response by some was also caused by a lack of awareness of the tornado, inaccurate assumptions about Joplin's vulnerability to tornadoes, and by distrust or confusion about Joplin's emergency communication system. These findings help explain why the fatalities and devastation was so great. With our findings in hand, the study team then looked at the current building code standards and practices to see what improvements might be possible. Current U.S. model building codes include requirements to protect against many different types of hazards, including hurricanes, earthquakes, and floods. They do not include requirements to protect against tornado hazards, which include extreme wind speeds and impact from windborne debris. The only exception where tornado hazards are considered is for safety-related buildings of nuclear power plants and for tornado-specific storm shelters or safe rooms. To drive home this point, buildings in Joplin performed as we expected. They were not designed to withstand tornado winds, and, not surprisingly, many failed. In addition, many tornado-prone areas, including Joplin in May 2011, do not mandate the construction of shelters or safe rooms. As a result, many residents, particularly those living in multifamily apartments and nursing homes, or those that found themselves in high occupancy buildings such as hospitals, schools, or large commercial spaces when the tornado struck, did not have sheltering options. There are also no nationally accepted standards for emergency communications to warn residents effectively of tornado hazards. To help address these needs, Nist developed 16 recommendations for improving how buildings and shelters are designed, constructed, and maintained in tornado-prone regions, and for improving emergency communications. I urge you to read the report available on the Nist website for the full list. Here are 3 key recommendations where implementation is likely to have the greatest impact. Number 1, develop national performance-based standards for tornado-resistant design of buildings and infrastructure, as well as design methods to achieve those standards, and require that essential facilities such as hospitals be designed to remain operational in the event of a tornado. Number 2, install tornado shelters in new and existing multifamily residential, commercial, and other buildings such as schools. Typically, the types of buildings we're talking about are called assembly occupancies in the building codes. This includes places such as large restaurants, places of worship, and theaters that accommodate 50 people or more at a time. As part of this effort, develop and implement uniform national guidelines to help communities design, install, and operate those shelters. Number 3, create national codes and standards for clear, consistent, and accurate emergency communications, and then ensure that emergency managers, the National Weather Service, and the news media and local communities have a joint plan for delivering those messages quickly and persuasively during tornadoes. We believe that these recommendations are realistic, appropriate, and achievable within a reasonable period of time. We strongly urge state and local authorities to adopt and enforce model building codes and standards that currently exist, and to update local codes as new standards aimed at improving resiliency to tornadoes are developed. We'd also like to stress that NIST is assigning top priority to work vigorously with the building and relevant communities, including other federal agencies, to assure that there's a complete understanding of the recommendations and to provide technical assistance for implementing these recommendations into standards and codes. Finally, we urge funding agencies to sponsor research on advanced measurement technologies that can provide faster warnings of dangerous winds, can quickly produce maps showing emergency managers which local areas are most likely to face the greatest hazards, and can push the appropriate warnings to residents in those areas in time to seek shelter. A single tornado affects a smaller geographic area than a hurricane or an earthquake, but tornadoes can happen much more frequently and kill more people in the U.S. each year than these other natural disasters combined. We know how to make structures that can withstand the majority of tornadoes, but so far we have not included protection against them in model codes and standards. We can save lives, minimize disruption to our communities, and lower the economic costs of tornadoes. The time is right to develop and implement codes and standards that better protect our citizens and help communities recover more quickly from these powerful but not invincible natural forces. At this point, I'd be happy to take your questions.
Webcast that they can send in email questions to joplinmedia@nist.gov.
Gary Kenny, KJPX TV, Channel 35, Joplin. You made the comment that there were some improvements that needed to be made in the emergency communications. Could you give some examples of some of the things that need to be repaired on that?
Well, currently, one of our recommendations is there are no standard practices for emergency communications, like for activating tornado sirens, how long sirens should sound for, what are the sounding patterns. We studied 75 different communities across the United States and determined that we need to have some standards for emergency communications. That's one of the major recommendations in our report.
So Gary Kenny again, so in talking about emergency communications, you're not talking about a failure of the communication system of the police department and fire department and so forth, and you're not talking about a failure of the emergency broadcast system?
Now, again, I want to stress that our report is fact-finding and not fault-finding. We're using what we learned here in Joplin about the emergency communications system in other tornadoes to make recommendations for improving national model codes and standards for the emergency communications network.
Is there anyone else? Okay.
So what type of improvements would you like to have done? What are these new codes? What will they implement?
Well, again, for emergency communications, it would start with the Weather Service, with forecasting, the warnings that are put out. We discuss in our report the communication of those warnings and forecasts and how they're given to emergency managers, how the media work together One of our recommendations is that these organizations need to work together and develop new technologies. We actually have another recommendation in our report aimed at NOAA that talks about some of the new research that they're hopefully getting ready to implement on some of the new practices and technologies that can help warn people about tornadoes in a timely and effective manner. We want to stress that we need to have collaboration and communication between people that put out warnings like the Weather Service, emergency managers, and the local media to effectively warn citizens about the impending threat of tornadoes.
We have a question from the Associated Press, Alan Zeiger in St. Louis. He would like to know who would have responsibility for enacting these recommendations and how likely are they to be enacted?
We have identified for each of our 16 recommendations in the report. If you look at Chapter 5, you'll see that we have interested stakeholders, people that would be important to bring to the table to help implement the recommendations, but we have named, in some cases it's a federal agency, in some cases it's a code or standard body, we have named a party responsible for implementing each of those 16 different recommendations. So you'll see that in the report. And there's a number of different organizations and agencies that we tag being responsible for implement them. The second part of the question about how likely are they going to be implemented, I can just say that the Nist is, as I mentioned in my opening statement, we're committed to, this is not the end of our efforts. We are committed to seeing that these recommendations be implemented. We're committed to working with code and standard bodies and other federal agencies to see that these recommendations help get implemented.
Hunter Peterson, KOAM, KFGX TV here in Joplin. Second page, you talk about you reached conclusions through looking at buildings, human behavior, emergency communications, and you say this is the first scientific study to address the intersection of all these things. Why is that? I've lived in Kansas and seen a lot of big tornadoes. Why is this the first study to go this in depth into this?
That's a good and interesting question. I think because it's difficult. If it would have been, if it was something that was easy, it would have been done already. It takes a commitment of expertise in a lot of different areas, and it takes a commitment of funding and time to study something like this with all these different subject areas. And we were fortunate to be able to do this for this investigation. And we think that really enhances the quality of the report and the quality of the recommendations.
And then you talked a lot about doing new things with building designs and how a lot of the buildings in Joplin weren't really built to withstand tornado strength. That's great looking into the future. What things can be done about buildings that are already here, especially a lot of the historical buildings in Joplin?
It's always more difficult and more expensive to retrofit existing buildings. There are ways, we know how to design buildings, we know how to retrofit buildings to withstand high winds, including windborne debris. In fact, the building codes in a lot of hurricane-prone areas have provisions for that. So we need to take some of those techniques, and one of the recommendations is to provide design guidance for people to understand how do we retrofit buildings, how do we design new buildings to withstand tornado hazards. So it is a very challenging thing to do to retrofit existing buildings, especially historical buildings, but it has been done successfully. And we recommend that we continue to make progress in that area. It's one of the recommendations in our report.
We have a question from Mike Hendricks of the Kansas City Star, who would like to know, do you have any idea how much it would add to the cost of residential and commercial buildings if these recommendations for building codes and standards are adopted?
That's another excellent question. There has been some work done with trying to build above code to have enhanced protection above and beyond what's currently in the code. And there has been some papers published in this area. There has been some work done on structures that go beyond code. For residential buildings, probably talking on the order of 5 to 15% for commercial and mercantile buildings, critical facilities such as hospitals, it would likely be more, but it also depends on what is the performance that we're trying to achieve. So once we define the performance that we want to achieve, we can then go and figure out how do we bridge that gap. And that's one of the recommendations we have, is to come up with design guidance that helps us bridge that gap to reach that performance objective. But engineers and architects, we know how to build buildings to withstand high winds. We just need to put out guidance, define the performance objectives, and then we can go in, after we've done this for a while, we can come in and come up with some harder cost numbers. But for residential, I would stick with in the 5 to 15% range. We can certainly make a lot of progress.
We have a follow-up question from Mike Hendricks of the Kansas City Star. Do you think there will be resistance from businesses to this added cost, and have you had some discussion with these parties already?
Well, again, we have, our draft report is out there for public comment, so we have not shared our recommendations with, today is when we're here sharing our recommendations. The increased cost, the way I mean, that's always an issue. These things that do not come for free. We're talking about enhancing the strength of buildings. However, over time, especially with new construction, that cost is usually much lower. Here in Joplin, I should remind you, we had over $2 billion of insured damages. Since 1950, when we started keeping records, we had 182 EF2 or greater tornadoes in Joplin within 80 miles, and 766 total for an average of 12.5 per year. So I think the case is made that the cost of not implementing some of these recommendations really affects community resiliency.
Any more questions from the audience? Reporters?
Thank you. Jared McCullough with KY3 in Springfield, Missouri. You talked about the fact that there was no community shelter available to the public. In your study, did you find whether or not, if there had been a community shelter, that the amount of lives lost would have been reduced significantly or at all?
Well, one of the findings that I mentioned in my opening statement is that there were no community shelters in place specifically designed for the standard. The ICC 500 standard is for a very high wind event. Certainly the lack of sheltering options. I also didn't mention that in Joplin, the large majority of the structures here do not have basements, so people did not have safe areas to go. Again, we know that shelters do save lives, and that's one of our recommendations in the report is to provide sheltering options for people in Joplin, so that if we have another event like this, there's a safe place for them to go. And our recommendation points out that, again, for assembly occupancies, do we need to have community shelters in all these buildings for new and existing structures.
Are there any other questions?
Wally Kennedy with the Joplin Globe. The recommendation to put shelters in nursing homes and places of high occupancy, is that due to the fact that in this event, a large percentage of people were killed because they did not have shelter in these type of facilities?
Yeah. One of our findings is that people had limited sheltering options. We also discussed in our report that areas that were designated as safe areas provided very little protection, and that people needed a safe place to go. We did have, as I mentioned, 84% of the people that died were in buildings, and in our report we actually go through a number of these different buildings and document what happened in the buildings. What were people told? Where did they go? Did they take shelter? Where were they likely when they either survived or did not survive? And again, one of our recommendations is that we know that the community shelters, when they're specifically designed for a tornado, work, and that we need to start putting those shelters into new structures with high assembly occupancies.
I guess another way to ask that question is, in terms of this event, did more people die in a building of high occupancy, or were they in individual structures, like a home?
I don't have the numbers in front of me. They're in the report, but I believe it was 60-some% of the people that died were in residential structures. Should check the report for the exact number, and it's somewhere around low 40s were in high occupancy buildings. So the majority of the people that perished in residential buildings, but a number of people did perish in high occupancy buildings as well.
Thank you. Next question was, did you establish the average wind speed for this tornado?
Well, average wind speed, we created a tornado model. Dr. Lombardo in front of us here created that, and we used that model to estimate wind speeds at different grid points during the tornado. So, and that will eventually be available on our website, that entire tornado model. So in the report, we estimate at different structures what the likely wind speed was at each of the locations. And then from those wind speeds, we tried to calculate what were the loads that caused that building to fail. And in many cases, they were well in excess of what the building code currently requires.
And what is that requirement? The building code requirement?
The building code requirement, I believe it's 110 miles per hour, a 3-second gust here in Joplin for most structures. Dr. Levitan, you want to correct me on that? I'm sorry, it's 115? So a lot of the wind loads that we estimated in the report were 150, 160, I think even 170 in some cases for some of the buildings. So they were well in excess of what would cause buildings to fail. And that's why in my opening statement I made the comment that buildings performed as we would expect. They're not designed for wind speeds and loads, and especially windborne debris that they were experienced during this particular event.
Thank you. Other questions? Any more questions online? Well, if not, let me remind everyone, both reporters that are here and also those online, that we will keep the email address joplinmedia@nist.gov open, and you can continue to send us questions. We will be in transit going back to Maryland fairly shortly, so we may not be available at all times, but we'll try to get back to you to the answers to your questions as quickly as possible. I'd like to thank everybody for coming to the briefing today and appreciate coverage of this story, especially letting the public know that the draft report is out for comment, and we'd like to get as much feedback as possible. Thank you all.